In the previous session, we have seen some basic commands where we have seen the different modes of the router, and in the different modes, we have something called user mode, privilege mode, global configuration mode, setup mode, Roman mode, line mode, like that. Okay, so where we have seen some basic commands. So now, the next part in this session, we are going to see something on how to. In this setup, we are going to see how the connectivity is established between the routers and what are the different types of connections which are used and the different types of WAN technologies. Okay, probably we'll see some basic introduction to different types of WAN technologies. So mostly in this class, in this session, we are going to focus on connectivity part. Now if you remember, router is a device which is going to provide a connection between two or more different locations. Like if you want to provide the connection between a LAN, let's say I have a LAN branch office site A, and I want to make sure that it should communicate with another branch office on site B of any company, let's say ABC company, site A and site B, and I want to make sure that these two different branch offices should communicate with each other. Then the first thing I need to do is I need to have a router on both the sides, and once you place a router, you have to make sure that your router is connecting to the LAN, and from router to router, that is from site A to site B, there should be a WAN connection which is given by the service provider. So now we'll try to understand some basic things, how the connectivity between these is established. Okay, that is something we are going to focus in this session here. So like take an example. Okay, so when you're connecting a switch to PC, we generally use one cable called straight cable. The straight cable is generally used. There are different types of cables here. In general, if we talk about different types of cables, we can say there is a straight cable, and then there is a cross cable, and then there is a rollover cable. The main difference between these three different types of cables is the color coding. In general, if I'm using any UTP cable, if I just try to take some diagram here. So now the basic difference between the straight through cable and the cross cable is, so in general, if you are using any UTP cable, unshielded twisted pair cable, which we use in our LANs, so it has, if you just open up that particular cable, it has 4 pairs of whites. You can see there: white, green, green, white, orange, blue, white, blue, gray, orange, white, brown, brown. Okay, so if you are going to arrange both the ends of the particular cable with the same color coding, generally we call it as a straight cable. So like here, if you just take an example, this is your jack, and this is your cable which is going to connect, okay, on the other ends. And if you're arranging alignment of your pins, the wires, if it is same on both the sides, like if you arrange same on both the sides, generally we call it as a copper straight through cable. Okay, so inside your RJ45 jack, and in case if you align your cable something differently like this, if you see when you're exchanging like 4 pairs of colors here, if I just take this diagram here, you can see here I'm going to use multiple colors here. So normally whatever the twisted pair cable which we are using, it is going to have 4 pairs of colors. So in that 4 pairs of colors, okay, so if both the sides have the same color code, you can see this is same color coding on both the sides. Then if you have same color coding on both the sides, then we call it as a straight cable. Okay, generally we refer this as a straight cable. But in case of cross cable, what we are going to do is we are going to rearrange the wire. Wherever there is green, we are going to replace with orange on the opposite end, and wherever there is orange, we are going to replace with green on the opposite end. You can see this is white green, and the other end is white orange, and this side is green, the opposite side is orange, and this side is white orange, opposite side will be white green, and here the last one, this side is orange and this side is green. So except these 4 colors, remaining all the colors are same, just like your straight cable. You can see this is same, this is same, and this is same, and this is same. And generally people say 1 3 2 6. We are rearranging 1 is going to connect to 3, and 2 is going to connect on 6, and similar ways 2 is going to connect on 6 and 1 is going to connect on 3. So just rearranging these wires on the opposite sides, generally we call it as a cross cable. So the signaling like whenever you are doing the physical connection in the LAN, it is a little bit important for you to have a basic understanding on which cable is used where in our LAN. Like generally we use straight cable if you want to connect mostly dissimilar devices. Like if you are connecting a router to a switch, we use the straight cable. And in case if you are hub or a switch, nowadays most commonly you'll find switches, and if you're connecting any switch or a hub to PC, we use straight cable. Okay, so dissimilar devices we can say. So similar way, if you are connecting similar devices, like if I'm connecting PC to PC, so generally we use cross cable here. And if you are connecting a switch to switch or switch to hub or hub to hub, hub to switch, we use cross cable. And in case if you are connecting PC to router also, we use cross cables. So PC to router means the way they send the signaling is same here. So here similar means the way they send the signals, not physically similar, the way they send the signals. So whenever you are, this is generally these lines will be considered as a transmitting signals, and this signals will this particular is considered as receiving signals. Here you can see these are generally considered as receiving signals. Okay, so based on this alignment, okay, based on this alignment of your wires, the copper wires inside the RJ45 jack, the straight cables or cross cables are differentiated. So similarly we got one more cable called rollover cable, which in other words we call it as a console cable. If you remember console connection we did in the previous session, so where we are going to use the color coding entirely opposite, like 1 2 3 4 5 6 7 8, and I'm going to use 1 2 3 4 5 6 7 opposite color coding. Okay, so in general we call this as 1 2 3. This is a standard color code we can say, not compulsory just to follow this code. You have to make sure that opposite side is blue, opposite side is blue. So if it is same, then in that case it works fine. And this side is green, opposite side is orange, it works fine for the cross cable. In case of straight cable, opposite side also will be same. Okay, so this is the default alignment of the wires. Based on this alignments we can say which cable is considered the straight cable or cross cable. So this is something which you are much familiar little bit when we talk about LAN network. This is something what generally we'll see in our real networks, where a router is going to connect to the switch via straight cable. So I'm going to use the same cable connecting on the Ethernet port, which is RJ45, maybe Ethernet, maybe fast Ethernet, maybe gig Ethernet, depending upon the model of the router. And similar way, when you're connecting from switch to PC also, we are going to use the same straight cable. So the LAN connection to the router is almost the same, the same cable which we use to connect from switch to PC, the same cable we use between router to switch also. Okay, but now the question is, what about the WAN connection? Now when we talk about WAN connection, so this is my branch office in Hyderabad, maybe this is my branch office in Bangalore. So I want to connect these two different branch offices, which is more than 500 kilometers. So it's far from each other, right? So when you have such a long distance connecting between the different branch offices, so the company, suppose I'm working for some company, maybe I'm working for some finance company. Okay, so the major business for me is to just the finance related things. So I cannot lay my own cable from Hyderabad to Bangalore to make sure that they connect with each other. So instead what I'm going to do is I'm going to contact the service provider, and the service provider is the one who is going to provide me the line, and I'm going to take the rent from service provider. I'm going to use the line from the service provider, and for that I'm going to reserve some specific amount of bandwidth depending upon your requirement, and I'm going to pay to the service provider for using his private network for sending the data over his. So in generally this is what we call as a private WAN. We call it as a private WAN connections, where only this particular link is a separate line given by the service provider for sending the traffic only between your branch offices. Okay, but when you talk about public WAN, that is internet, which we are much familiar. So here in most of these cases we are not using internet, we are going to use a private WAN connection which is given by the service provider. So now we are going to try to understand here how the WAN connection is established between the different locations given by the service provider. Okay, so now to provide this WAN connection, there are many technologies we can use, like roughly to say there is something called leased line connections, We have a packet switching technology like frame relay, ATM, and X.25 no more used. ATM, frame X.25 no more used. Frame relay is also not much used as of now because these are mostly outdated technologies. Leased LANs is one of the most commonly used technology, even though it is very expensive, but still it is the most commonly used technology here. Apart from that, you have something called circuit switching technology, which is going to use your existing telephone lines, and you got, like, in that circuit switching again there is ISDN technology, PSTN technologies, and then we have other technologies like MPLS technology, VPN technology. There are a lot of technologies, okay, which can be used to provide a WAN connection. So we'll get into these different types of technologies more in detail in the next sessions. We are going to discuss more in detail about these different types of WAN technologies in detail in a separate session. But here we are going to try to understand what is the default structure or the default design, the default connectivity type, how the service provider is going to provide the connectivity between your branch office, which is in different location, maybe in Hyderabad and maybe in Bangalore. So I want to make sure that these two branch offices should communicate with each other, and now how the WAN connection will be given by the service provider. Okay, so now to take the WAN connection, first thing you need to contact the service provider. So we got different types of technologies which I just discussed. WAN connections, we got circuit switching, packet switching technology, and dedicated lines. Probably we'll get into these things more in detail in the later on classes. So this is the one of the example of how the circuit switching technology looks. Okay, so let me just take this diagram here. This is how the service provider is going to provide the line here. Okay, so now if I just take an example, you can see the diagram here. So now assume that I got a LAN here which is going to connect my branch office here. So you can see here already in the diagram, this is my LAN which I'm going to connect, which is in Hyderabad branch office, let's say site A. Okay, you can simply give some name as site A. So what I need to do is I want to make sure that my site A location should be able to communicate with site B LAN. So both are different, far from each other, and the distance is more than 500 kilometers between the two different locations, or it can be more than that. So now I have a branch office here, LAN here, and I got another branch office, LAN here, which is site A, site B. Okay, I want to make sure that these two different branch offices should exchange the routes, should start communication. Okay, so to make this possible, what I need to do is I need to contact the first thing, I need to have a router on both the sides, and I did the connection of the router to the LAN using a straight cable. So this connection is something which is in our hands, so I can do it. But now the question is, what about the WAN connection? What about the connection from site A to site B, which is far from each other between the two different LANs? So I need to contact the service provider. So service provider is going to place some modems. Generally we call this as leased line modems, or technically we can call them as V.35 modems, which are separate modems which are used in leased line connections. Okay, so these modems are responsible for sending your signals over the service provider network in the form of analog signals. Okay, so now these modems are totally different with the modems which we use for internet connections. So whatever the modems we use for internet connections, maybe generally we call them as DSL modems, which will convert your digital to analog signals. At the same time, it will allow you to send your telephone line. Means you are using the existing telephone line, and also you are using telephone line as well as you are using internet. So this is different modems. We're not talking about those DSL modems, and also I'm not talking about any cable modem technology, the normal broadband modems which we use in most of our internet connections. So these modems are totally different modems when compared with our internet modems. So these are specialized modems which are designed for leased lines. Okay, so generally we call them as V.35 modems. In other words, we call it as a CSU DSU devices, a channel service unit, data service unit. So probably we call them as CSU DSU devices. So service provider is going to place a modem in your location, and then is going to provide a WAN connection between your router to the nearest modem. And then up to this point you can see this part, we call it as CPE. So CPE stands for customer premises equipment, means this part is your customer premises equipment which is in my hands. Means I can control if something goes wrong. Let's say the connection between router to modem goes down, then it's your responsibility to fix it. That is your job, day-to-day activity you have to do. Monitoring, you have to check, make sure that the link is up. If something goes wrong here, something goes wrong in the LAN, some problem in the any of the device, some problem with the router. So this is something what a customer premises equipment we call it as a, which is the responsibility of the customer and to ensure that everything is working fine. But after this V.35 modem, it is not in our hands, because from this V.35 modem there is a 2 pair wire which is going. You can see on the left side very much clearly, okay, which is going to connect to another modem. Generally we call this as G.703 modem, which is generally we call them as long distance modems, generally found on the service provider networks. And then it is going to connect to another device called MUX. MUX stands for multiplexer. So now from here there is a 2 pair wire. This is your 2 pair wire which is going to connect to another modem here. Now this particular point, now this we call as, this is your the yellow line you can see there, this is your exchange office. So exchange office of site A, maybe whatever the nearest exchange office of the service provider. So just like your home internet connections, if you take normal home internet connection, let's say this is my PC where I'm going to take internet connection. So service provider, if I ask my service provider to provide me internet connection or cable TV connection, so what he's going to do is he's going to take a nearest box, probably the nearest switch box placed in the top of the building, or it can be on the nearest buildings. He's going to pull one cable. From that cable he's going to bring that cable and connect to my PC, probably maybe to modem as well, or it can be a router as well, wireless routers. And then from there he's going to connect to the nearest box, and from that nearest box again it is connecting to your exchange office, from where all your data travels. Similar way here also, the same thing, the service provider connects your V.35 modem here, and that modem connects to another modem on the service provider exchange office, and then it is going to connect to another device called a multiplexer. Okay, so now same thing happens on the other end also. It connects to V.35 modem, and then it is going to connect to another modem on G.703, and then connecting to a device called MUX. So this is the exchange office of site B, whatever the location we can say. And from Hyderabad MUX to Bangalore MUX there is a fiber optic line given by the provider. You can see this is your fiber optic line, which is pre-existing, which is connecting the major countries or major cities, and which is already laid by the service provider and maintained by the service providers. Okay, so it is something maintained by the service. So now similar way there is a fiber optic lines connecting the different cities and maybe different countries, generally provided by the big service providers. If you take any country level service providers, they generally provide the line. There's a pre-existing fiber cables connecting the major cities as well as major countries. So generally we call them as submarine cable maps, where most of the locations are connected through the different service providers. Okay, so now if you just talk about here in this, so this is how the service provider is going to provide the connectivity here. Okay, let me just quickly revise one more time. Okay, so here we are going to use so probably you can see the map here. These are the pre-existing submarine cables connecting the major countries here. These are the pre-existing lines connecting the major countries here by different major service providers. Like, you know, there are different service providers. If we talk about India, like you got a 4 major service providers, which is BSNL, Tata, Bharti, Airtel, Reliance, okay, which are generally connecting to major cities here. And then the 8 submarine cables connecting India to the world, or like Southeast Asia, Middle East, Western Europe. This cable is going to connect from Western Europe. So these are the pre-existing cables laid by the service providers, which is connecting the major countries. Okay, so like there are different service providers we can say. You can see one more diagram here. Okay, So like that, there are different service providers, all are connected to each other. So like you can see here, these are the different types of service with different providers. Now there is no single provider who is going to connect, but there are major service providers. The biggest service providers get into these things, and they have a pre-existing connections here. Okay, so the main thing is here, if you talk about the different types of WAN connections, so whatever the technology, generally we call them as leased LAN connections, where between the service provider exchange offices there is a pre-existing connection. Okay, okay, so there's a pre-existing WAN connection given by the service provider. And the example which we took here, this example is a basic example of leased lines. So even though service provider is going to provide the connectivity, so now here we got a router connecting to. So when you talk about the WAN connection is something given by the service provider, and there are many devices involved here. In between you have some modems, you have multiplexer devices. The main job of multiplexer is it is going to provide multiple input connections. Like, you know, the general meaning of multiplexer is providing multiple inputs. So even though you are sending multiple signals over the same cable, but still each and every signal is differentiated, and that is the job of multiplexer. Like if you take an example of any TV cable, if you just take an example of normal cable TV operators, okay, so from the same black cable which we connect to our television, so the same cable is going to carry hundreds of channels, but each and every channel is differentiated. Even though they go from the same cable, but each and every signal is differentiated with a different frequency. Okay, that is what frequency division multiplexing, and that is what multiplexing is, the meaning generally we call as. So similar way here also, maybe on the same location there are many customers connecting same way like this customer is connected, but even though you are providing hundreds of connections maybe on the same device, maybe the same cable, but you have a pre-existing bunch of fiber optic cables connecting between the different exchange offices, but maybe there are multiple customer traffic going on the same cable, but still they are not interfering with each other because each and every signal is differentiated with a different frequency. Generally we call as frequency division multiplexing if you get into some electronic technology, but that is the job of multiplexer here. And then modems will generate some clocking which will help you send your data to go over longer distance. Mostly this is converting into analog circuits, and all your data is going in the form of some analog circuits which a service provider will understand. So service provider network mostly it is an analog circuit. Okay, so this is how the default structure, generally we can say the default structure of a customer or a service provider network will be. But we don't really need to get into all these things because we have nothing to do on this particular part, and our main job majorly, unless and until you are working for a service provider, we don't get into this particular part. Okay, and we don't get into this particular part also. This is more like similar to your telecom network. Okay, it's not complete telecom network, but it's more like that. So majorly we work on this particular part, and majorly we work on this particular part. And then when we say that there is a WAN connection, we just draw one zigzag line representing that there is a WAN connection given by the service provider. Okay, and then when you represent that we have a network, we have some router, and then it is connecting to some other router here, connecting to some other router here, again connecting to some other router. I got some 5 branch offices, 1 2 3 4 5, and each and every branch office is having its own LAN, but still we just represent that there is a WAN connection between these routers. But when you talk about WAN, there are many devices involved, and majorly service provider is responsible for providing you the WAN connections. Okay, so that is one basic example how the connectivity is established here. Okay, so I hope this example will give some little bit basic idea on how the service provider is going to provide the WAN connections. So we are not using any internet lines. Internet is a separate line which is used to connect your public network where everyone is connected, but the network which you are going to use between to connect between our locations, we call that as private WAN, where only our organization routers are connected, and we are only sending and receiving our information between the branch offices. Okay, so now the next part, example of a leased LAN connection, how it will be. Now the next thing we need to understand is just a basic difference. In this setup we got two different types of devices here. In this setup we got two different types of devices. In general we call them as DT device and DC devices. We got two types of devices here, DT and DC. Now the basic difference between these two is, just like if you talk about a normal WAN connection, if I just take an example of a normal dial-up internet connection, suppose I'm using dial-up internet connection, I'm going to connect my PC to a modem, and through the modem I'm going to connecting to the telecom line. So if you remember some basic dial-up connections, still we use some of the basic example of dial-up connections. It's not completely dial-up like the USB modems which we use data cards. So probably there is one basic example of this, but initially we generally still use these things where we connect a modem and which is going to connect your telephone lines, and we are connecting to internet. Like if you're using your mobile phone and connecting to your laptop and you're using the internet, the mobile phone is acting as your modem in general. So in this setup there are two different types of devices here, and we call this computer as a DT device, and the modem is acting as my DC device. DT stands for data terminal equipment. DT stands for data terminal equipment. DC stands for data communication equipment. So the main difference between these two is the DT is going to receive the signaling. Clocking means signaling, whereas DCE generally we call it as DC devices which will going to generate the clocking, whereas DT is going to accept the clocking. Clocking is nothing but I can say clocking term, I can use it as helping the data to send over longer distances. Now modem is a device in general, as per our basic knowledge or basic understanding of networking, we generally say that modem is a device which is going to receive the digital signals and it is going to convert into equivalent analog signals which a telephone network understand and then reaches the internet. That is something what generally we say. Anyway, it will do that particular signaling part, it will take care. It is going to convert to equivalent signals which is understood by the service provider. That is the main job of the modem here. If you take this modem or this modem, both are same. So this modem also is going to do the same job, which is going to take the signals from the router and it is sending over the service provider network into equivalent maybe analog signals or whatever the signals which service provider understands. So depending upon the type of the modems, we got a lot of variations of modems into that. So now this DC device is going to generate some clocking which is going to help to send your data over longer distances. So the thing about clocking is, I can say clock speed or generating the speed for your data, and modems by default they do generate the clocking which helps your data to send over longer distances, whereas DC devices only receive the clocking or they just receive the clock speed or they receive the signals, that's it. So the same example if I take here a router, if I same example takes example here also the router is your DT device and the modem is your DC device. So now the modem is going to generate the clocking which is required to send your data over longer distances. Clocking means just like you can say pumping the data or helping the data to send over longer distances, which is going to send your data over the longer distances, whereas DTE is going to receive the signaling. So in order to communicate between two or more different locations, like I have a router here which is DT device and I'm going to exchange the information between another router which is on a different location, that is also DT device, compulsory in between you need to have a DC device, which means modems and MUX. So in this setup, this modems are your DC devices and this also is your DC devices. The complete exchange setup of the service provider acting as a DC devices, communication equipments which will help to communicate. Okay, so that's a basic a basic terminology I can say, which you need to have some basic understanding on what is the DCE and what is DC devices. Example of DC is your leased LAN setup, which is V.35 modems, G.703 modems, and in case of a normal example, we can say a dial-up modems. Like if you take an example, just now I took one example, dial-up modems here. And DTE, data terminal equipment, which is going to accept the clocking. In leased lines, routers are considered as the DTE devices. In our normal examples, computer. So this is my DTE device, this is my DTE device. So just a basic understanding we need to know. Connecting to hardware requirements. So leased LAN modems also called as CSU DSU modems. Generally we call as channel service unit, data service unit devices, which is going to generate the clock rate. So now when it comes to lab scenarios, now the next thing is, okay, so we got some basic understanding on, okay, the connectivity, how the connectivity is provided and how the connectivity looks when you get into real production networks. But in our lab scenarios, when you are connecting real devices here, we have a router, we have two routers. So probably we cannot take the real exchange setup here. So to simulate the real exchange WAN setup, we are going to use one cable called back-to-back cable. So we're going to use one cable called back-to-back cable, which looks similar to this one. You can see the snapshot of this back-to-back cable. You may find in most of the lab scenarios, in the labs, you will find this cable is connecting between router to router. It will be 60 pins. You can see this connector is 60 pins. Also you'll find 26 pin also. We call this as V.35 back-to-back cable. Now what this cable is going to do is, this back-to-back cable is used to emulate the copper wires, the modems and the mux, which means this back-to-back cable, if I connect between the two routers, it is equivalent to connecting to V.35 modem and then connecting to G.703 modem and then connecting to mux, something like this. So it is going to simulate the so we can say it is going to emulate your complete exchange setup, because when you get into production networks, you exactly see this type of networks where you are connecting a router to modem, all these things. But here in our lab scenarios, we cannot use this setup. So instead we are just assuming that there is a WAN connection between the routers by connecting this back-to-back cable. Okay, so that is something what a small adjustment we are going to do when we are implementing the labs on the routers. Okay, so one more thing we need to keep in mind, without DCE, DTE devices will not be able to communicate. The communication is not possible, but don't worry, here it is possible, because let me give you why. By default, let's say I got a router here and I'm going to connect a router and I'm going to connect one back-to-back cable between them. So router is a DTE device, router is a DTE device. So the communication, the signaling between DTE will not be understood in general. So what this cable will do is, this will convert one side of the interface to DC and one side of the interface will be still DTE. So now the communication happens with this back-to-back cable. So now this back-to-back cable is going to emulate your complete exchange setup. At the same time, it is also converting one side to DTE, other side is DC. Because in the real setup, we are connecting to V.35 modems, which is your DC device, and the router is your DTE device. So but here, the back-to-back cable is automatically converting one side to DTE, one side to DC. And if in case if you want to verify which side is DTE, which side is DCE, you can use one command called show controllers, and whatever the port number, let's say I'm connecting port number as 0 on this side, you can use this command in this mode to verify, but not really required, because it's a lab specific command, not much applicable in the real production networks. Or else you can see on the back side, mostly it will be written here on that side. Sometimes in most of the cables I have seen. Okay, so while practicing labs, we use V.35 cable, back-to-back cable connection with a router, whereas in the real time we use V.35 cables, which is going to connect to the leased modems. That's the reason we use clock rate command. I'll come to this clock rate command when I start the labs. And in general, there are some different standards given. Like whenever anyone say E0 line, generally in UK, standards as per the UK standards. Okay, I think different speed E, as well as in UK it is identified with the letter T. So we got different standards. In United States we generally refer as a T1 line. So whenever anyone say T1 line, means you have to understand that we are using a 1.5 Mbps line. T2 represents 4 T1 lines, means around 16 Mbps line. T3 represents 45 Mbps line. T4 represents 275 Mbps line connecting between the two routers. So sometimes we represent in this terminology. So I'm going to have a leased LAN connection between these two routers, and it's a T1 line. So whenever anyone say T1 line, means this is the speed of that particular line. Similar way, in European countries generally it will be referred as E standards, E1, E2, E3, E4, like this. Okay, so now probably in this video we have seen how the connectivity is given by the service provider, especially on the WAN, because the LAN is something where we can see how it works, because it's a simple straight cable connecting. But when you talk about WAN connection, it is given by the service provider. We don't do much on the service provider network, but here I have given you the basic example, like how the leased LAN connections will be established and how the connectivity will be done, and what are the different devices used by the service providers to provide the connectivity between two different locations. But our main focus here in the CCNA will be, we are going to focus on this particular part, because this is something service provider and we are not going to do much on the service provider side. But our job is to make sure that if something goes wrong, you have to make sure that service provider should make the link up as soon as possible, because if that link fails, then it will affect my communication. Depending upon the agreement with the service provider, you have to just contact the service provider and make sure that the link is up as soon as possible. So probably in the next video we'll see also see the basic IP addressing configurations, where we'll see how to assign the IP address and all those things. Okay, thank you.